We now have lists and dictionaries under our command, and so we have a lot more things that we can do right now. So in today's programming tips, we're going to first see another way that we can iterate over lists. And secondly, we're going to look at a variety of common mistakes, primarily involving lists and dictionaries. So what we're going to do is introduce a new way of looping. But first, we're going to see a common form of a for loop that we have already been able to write. Okay, so specifically this function is going to build a new list that has the square of each number in the input list. So first, let's make sure it works. Okay, so 4 squared is 16, 5 squared 25, negative 2 squared 4. Sure, it works. Okay, so what's going on in the function? We first initialize our return list to be empty, and then for each element of our input list, we're going to add an element to our output list, which is the appropriate number squared, and then we return. Okay, so this is a very common pattern of we're doing something for every single element of the list, and then we're building up a list of all the results and returning that result. Okay, so there's another way of doing this that is much shorter and arguably a lot simpler. Okay, so I'm going to define square list 2, and it's going to look the same here. And all I'm going to do is I'm going to return, okay, and well, I start it with a left square bracket like a list. What I'm going to say is going to look pretty much like a list, a loop, but the parts are going to be in different order here. So I'm going to say I want to have in the list n squared for n in the list for each element of my list. Okay. So let's see if that does the right thing. I'm going to change my test call to use that new function, run that, and it returns the same result. So here's the first example of what we call a list comprehension. Okay, it's surrounded in square brackets like a list, and inside it looks kind of like a loop. Okay, we have 4n in numbers, just like original here. And what we are doing is what we want is each number is going to be squared for n. Okay, and that's all there is to it. Next, we'll see another example. Here's another common example of how we can structure a loop. So here we have, in this function, balls in range 1, we want to check if the given balls are within a specified range that we set up within a specified rectangle area. So what we're doing is for each one, we're going to just test, is it in range? Okay. Now, what actually this helper function is doing doesn't really matter, but it's checking if, some point is within a rectangle. Okay. And so, but let's focus on this loop. Okay. Once again, we're going to initialize our resulting output with the empty list. And then for each ball, we're going to check if it's in range. If it is, we're going to add it to the output. And then at the end, we return the computed list. Okay. So that's a very common sort of thing. We often call that filtering in terms of what we're wanting to do. We're filtering out the elements we don't want. List comprehensions also provide us a way to do this. Okay, so I'm going to define another version of this function that does the same thing. That is, once again, much shorter. Okay. So all I'm going to do here is return. Once again, I'm going to have a list comprehension that all I want to do, the computation I want to do on each element is simply return the ball for ball in balls. But I also want to check if it's actually in range. Okay, so if is in range ball. Okay, all right, so first of all, testing with our original function, we see that only 2 of the balls are in range. Okay, so let's make sure that the same thing happens when we try it with our new version. We get the same 2 balls. The same 2 points are in the specified range, have the desired property. Okay, so here looking at our result again, the code that we came up with, the list comprehension, and once again, square brackets. We can do computation. Here we don't do any computation on each element, we just return it. For what elements are we looping over? And here, this time, the interesting thing is that we are testing whether we actually want to use this element. Okay, and it needs to pass this helper function. Okay. So let's start to look at what can go wrong when we're using lists. The first thing that we're going to look at is probably the most common mistake there is. And to illustrate, I'm going to define a list with just range, something really simple. And so I'll print out the length of that. And of course, it's length 5. Okay, so that makes it awfully tempting to say, let's look at the fifth element. Of course, we get an index error out of range. What's the problem? Remember that the indices are numbered 0 through 4, not 1 through 5. Okay. A variation upon this theme here would be to ask for L of len L. Okay. And so of course, we get the same error. Okay. There's another common way that we run into this, okay, which I'll illustrate here. In this example, what we'll do is print out pairs of elements. Okay, so for I in range 5, what I want to do is print out L sub I and L sub I plus 1. Okay. So once again, we get an index out of range. Okay, we print out the pair 0, 1, 1, 2, then 2, 3, then 3, 4, then 4, and oh, once again, there's no element to pair up with 4. There's no element 5. Okay. So beware, this is known as an off by 1 error, because you're so used to counting from 1, but now you need to think in terms of counting from 0. So now we're going to compare lists and dictionaries. They're similar in a lot of ways, but where they're different, that's where people make mistakes. So let's look at this example here. L maps index 0 to A, 1 to B, 2 to C, 3 to D. Similarly, the dictionary D maps key 0 to A, 1 to B, 2 to C, and 3 to D. And then some other stuff we'll look at later. Okay, so for both of them, we can say print L of 2, print D of 2, and they both give us the string C. But the dictionary has some other things here in it as well. So for example, we could print out D of the string XYZ. That'll give us the value 50. Okay. So notice that I actually use different words here. The indices of a list must be contiguous integers starting from 0, going up to the length of the list minus 1. The dictionary keys can be integers as well, but they don't have to be contiguous. And there can be other things as well. Okay, now there's several consequences of this. So first of all, notice that for lists, as we've seen, we can look at what's the last one. So print out L minus 1. Okay. And that prints out D. It's the last thing in the list. But what about for dictionaries? Is there a last thing? Well, does 0 come before or after the string XYZ? Does 3 come before or after true? I don't know. Nothing really makes sense there. So in fact, dictionaries are not considered to be ordered. Okay, there is no first or last element. So one consequence there, we can print out D of minus 1, and what's going to happen? Well, it looks for minus 1 as one of the keys, and it's not there, so it complains. Okay. Here's another consequence. Okay, well, slices. Okay, so comment that out. Okay, we can do slices on lists. Okay, that prints out a section of the list. But what if we tried to do the same thing on a dictionary? Well, since there's no ordering, it doesn't make sense to ask for kind of a section of the dictionary, okay? Because what keys are in that group? Does that include true or not? I don't know. Okay, so we can't do that. One other consequence here. What if we print out the list L and print out the list, the dictionary D, the whole thing? Okay, the list is going to print out in A, B, C, D. They're ordered. It's going to print out in that order. What about for the dictionary? Well, it's going to print out in some order, but it's not necessarily the order that you expect and not necessarily the order that you typed in. In this case, note that XYZ came before 719 and 1.5 came after 719. Why? Well, it's all due to just how the internal representation turns out to be. Okay. In short, it's not going to be a predictable ordering. Okay. Well, what else? Okay, you can also mutate dictionaries and lists. So we can say something like, let's mutate L of 2 is going to be wow, and D of 2 is going to be wow. Okay, and so we can print out the list and print out the dictionary. And in fact, we've changed position 2, index 2 of the list to be wow, and then 2 maps to wow in the dictionary as well. Okay. But what else can we do when we're mutating? Okay. Well, what if we instead wanted to mutate position 50? Okay. Notice that, let's see, 500 here. Notice that 500 is not in the list or the dictionary. Okay. It's going to complain about trying to change the list position 500 because, well, that's not within the range. We have defined it 0 through 3. 500 is not within that range, so it complains. So, well, let's comment that out. However, we can do that with a dictionary. We can change 500, and well, since 500 wasn't there, it's simply adding it in. Okay. So, we saw previously that dictionaries can have a whole bunch of things as keys. For example, integers. They don't have to be consecutive. They can be floating point. You can have strings. You can have booleans. What else can you have? Okay, so let's try here a dictionary of a tuple, mapping a tuple to something. Okay, see if that works. Sure, that's fine. How about a list? No, that gives us a weird error here. Type error, unhashable type list. Okay. Let's try something else. For now, let me just comment that out. Let's try a dictionary. Okay, dictionary, let's update it and just put an empty dictionary there, equal to 10. Okay, unhashable type dict. Okay, so we can't do that either. Okay, so what does it mean by unhashable type? Long explanation is outside the scope of this course, but the basic idea is an unhashable type is any mutable type. Okay, so we've seen lists and dictionaries. Those are both mutable. They cannot be keys in your dictionary. They can be values in your dictionary. So for example, just coming up here, D of the tuple 1, 2 is going to map to an empty dictionary. Sure, that works out fine here. That 1, 2 is going to map to the empty dictionary. So you can have anything as key values, but only immutable values as your keys in a dictionary. Lastly for today, a couple things about when you're loading images. So first of all, here I just have a simple program that's going to load an image. It doesn't even try to do anything with it. But clearly this URL is bogus. It's not going to work. Notice there's no error when I run it. So if you have the wrong URL, it's not going to complain. Be very careful. Secondly, when you do have a valid URL there and are loading an image, images can be large. So especially loading an image over the network can take some time. While it is loading, remember that if you ask for the width or the height of the image, you'll get 0 until it's actually been loaded. You'll also see a delay in your program. The image won't be there while other things are going on until it finally loads. Okay, that's it for this week. See you next week.